let's see if we can find the derivative of at some constant to the x. Just pretend, you could pretend it's the number 2. That's usually the one I personally think of, but whatever. How can you do that by definition? Well, by definition, we want h to go to 0. We want whatever it is, wherever the variable is, it's going to be x plus h. And we're going to take away the original function, and we're going to divide it by h. Now, you know, after you've done many of these, you're always trying to get rid of that h in the bottom. Always. Always trying to get rid of it. So how am I going to do that if h is stuck in the numerator? And you know what the truth is? I don't even know. The truth is, I have no idea how you can do something like that. So I'm just going to have to play with it. I know from algebra a couple tricks, like way back when x squared times x cubed was just adding them. That would be x to the 5th. So I think I could say that x to the, or a to the x plus h could also be written as a to the x, a to the h. And the only reason why I'm doing that is because I'm trying to somehow pull this thing apart, and I don't know how to do it. So I have to find, like, how can you pull something like that apart? Okay, so I don't know, but we're going to try to find it. So let me argue with my pen for a second. So from there, we have the limit as h approaches 0, a to the x times a to the h minus a to the x over h. And right now, that doesn't seem like it helped me in any way. I don't see how that was very helpful at all. Because I still have h in the exponent, and I need to divide it out somehow. So I seem stuck. I'm hoping there's something else I can do, and I'm trying to think what that is. I have a to the x and a to the x. So I'm wondering, again, this is just more algebra, not so much calculus yet. I'm wondering if I can't pull one of those out and just see what happens. A to the h minus a, well, actually that's just 1 now, over h. Okay. So I'm trying to take the derivative of this thing, and then it just got pulled out. And then now I have a to the h minus 1 over h. This is crazy. So now the thing I'm trying to take the derivative of doesn't even have the h anymore. And I'm stuck with a to the h minus 1 over h. So right now I have no idea where this is going, because the h is stuck in the exponent still. After all these steps, it's still stuck. So what am I going to do? Well, I don't know, but I think I'm going to try another very weird algebra trick and see if it helps. So I'm going to say, technically, a to the h is the same thing as e to the h times the natural log, and then in this case that would be a, but whatever number you're using, if it's not a, if it's 2, you'd plug in 2. Technically this is true. Technically this is true. And if I can say that, maybe I can rewrite this and take the limit of this. Okay. So if that's true, let's see what it might do. So this is a to the x. Again, that's the thing I'm trying to take derivative of, and now it popped out. So that's kind of crazy. H to 0. And now we have something even uglier than what we started with. H, the natural log of a. And then we have a minus 1 over... and h. Okay, now h is going to 0. H is going to 0, right? So as h goes to 0, this exponent is going to go to 0, because this is like natural log of 2 or 3 or something like that. So as h goes to 0, the exponent goes to 0, and that's e to the 0th, which is 1. And that's 1 minus 1. So the numerator will go towards 0. The denominator will go towards 0. So you're going towards a to the x times 0 over 0. And we know that when we get 0 over 0, that's more of an intermediate form, and so we need to do some more work on this, okay? How are you going to do more work? Well, again, we're kind of here. How are we going to do this? So we have to really think about how we might tackle something like this. So we need another fancy technique to do this. So I'm thinking that if we took the derivative of both top and bottom, it might do. So there's a thing called L'Hopital's rule. And in my day, my classmates and I used to joke that this was a little hospital, but we are in the Midwest, so you'll have to excuse our poor sense of humor. But L'Hopital's rule claims that you could take the derivative, both top and bottom, if you have that 0 over 0. And that's exactly what we have. So I'm going to write what we have here. And we still have a to the x, which again, that's what we're trying to take the derivative of. Okay. So the limit as h approaches 0. Now here comes the crazy stuff. I am going to take the derivative, since this h is what I'm concerned with. I'm going to take the derivative with respect to h. Okay, that's kind of crazy, but I'm going to do it top and bottom. Okay, kind of crazy, but I think it might serve us. We will see. Okay, we can see that if I took the derivative of the h on the bottom with respect to h, it just goes to 1. This negative 1 here is going to go to 0. And then e to the h ln of a, remember, ln of a is just a number. It's like natural log of 2. And what it's going to do is it's just going to come down, and you're going to take it with respect to e to the h, and you're just going to get e to the h. Okay? So this, I think, will be my last step. So a to the x, limit as h approaches 0. And what's going to happen is I'm going to get natural log of a times e to the h. And now I'm finally going to let h go to 0. When h goes to 0, this e to the h will go to 1. And so I will be left with a to the x, the natural log of a. And so that is what I think the derivative is. Now, I know that because it's something we memorize in class. I know that to be true. And that also kind of helps me. So this is a solved problem. I'm not solving it from, I'm not the first person to do this. So context can be nice if you're learning this stuff, right? But hopefully you find that kind of helpful of being walked through that proof. But that is the derivative of a to the x, and so if it was 2, if a was 2, it would be 2 to the x natural log of 2, and that's what we generally just memorize in class.